Welcome to Professor Bernard's channel. This video tries to introduce C-string. Let's dive in. C-strings are sequences of characters represented as null-terminated character arrays. Each string ends with a null character, \0, that marks the string's endpoint. C-string arrays have a fixed size declared at initialization, with enough space for characters and a null terminator. Here, name is declared as a character array. The size of the array is determined automatically based on the length of the string Fanshawe plus one additional byte for the null character that is automatically appended by the compiler. Therefore, name will have a size of 8 characters and Fanshawe plus one null character. Here, name is declared as a character array with a fixed size of 5. However, since it's declared without an initializer, it contains garbage values because it hasn't been initialized explicitly. In this case, since there's no explicit initialization with a string literal that includes a null terminator, the name array doesn't automatically have the null character \0 appended at the end. Therefore, it doesn't represent a valid C-string. Instead, it's just a character array with undefined values. It's important to note that when working with C-strings, you need to ensure that there's enough space in the character array to hold the string characters plus the null terminator. Otherwise, you risk encountering undefined behavior or buffer overflow issues. Here, name is declared as a character array with a fixed size of 5. The initializer \0 initializes all elements of the array with the null character \0. Now, because every string in C is terminated by the null character \0, this initialization ensures that name represents an empty string. The null character at the end signifies the end of the string. So, after this declaration, name contains the null character \0 repeated 5 times. This means that name represents an empty string, as there are no characters before the null terminator. It's worth noting that while this array is initialized with null characters, it's still a fixed size array and can be modified later to hold a string of characters, provided it has enough space to accommodate both the characters and the null terminator. Here, name is declared as a character array without specifying its size explicitly. The size of the array is automatically determined based on the number of elements provided within the curly braces during initialization. However, there is no explicit null character \0 included in the initialization list. In C, strings are expected to be null terminated, meaning they must end with a null character to indicate the end of the string. In this case, since there is no explicit null character provided, the string stored in name is not properly null terminated. This means that the code technically doesn't represent a valid C string. It's just a character array holding the characters F, A, N, Z, H, A, W, and E, but without the null terminator. To ensure name represents a proper C string, you would need to include a null character explicitly at the end of the initialization list, like so. Char name equals F, A, N, Z, H, A, W, E, \0. This way, the string Fanshawe stored in name will be properly null terminated, making it a valid C string. When the user enters their first name and hits the enter key, scanf automatically appends a null character \0 at the end of the character stored in the name array. This null character marks the end of the string, making name a valid C string. So, after the user enters their first name, the name array contains the characters of the entered name followed by a null character \0, effectively making it a C string. Here, name is declared as a pointer to a character, char. It is initialized with the address of the string literal Fanshawe. In C, when you initialize a pointer with a string literal like this, the compiler automatically appends a null character \0 at the end of the string. This means that the string Fanshawe stored in memory is terminated with a null character, making it a valid C string. So, name points to the first character of the string Fanshawe, and the string is null terminated, ensuring that it's properly represented as a C string. This approach is convenient because it allows you to work with strings without explicitly specifying the size of the character array, as the compiler takes care of appending the null terminator automatically. The string library provides functions for manipulating C-style strings. Some commonly used functions in string include: 1. Strlen s1 returns the length of the C string, not including the null terminator. 2. Strucat s1, s2, void function appends the contents of s2 to s1. 3. Struct ps1, s2, void function copies the contents of s2 to s1. 4. Strncat s1, s2, n, void function appends at most n number of characters from s2 to s1. 5. String ps1, s2, n, void function copies at most n number of characters from s2 to s1. If n less than or equal to s2 length, the null terminator is not appended to s1. If n greater than s2 length, s1 is padded with \0 characters. 6. strcmp s1, s2, returns an int based on the comparison of s2 to s1. If s1 equals s2, returns 0. If s2 is lexicographically greater than s1, returns a value less than 0. If s2 is lexicographically less than s1, returns a value greater than 0. 7. strstrs1, s2, searches for the first occurrence of s2 in s1. Returns a pointer to s2, if found. Otherwise, returns null. The following C-string functions under stflib.h convert a C-string representation of a number to a numeric data type. The argument must be a C-string or can be a converted string. 1. Autoi function returns an integer representation of the C-string argument. 2. Adolf function returns a long representation of the C-string argument. 3. Atod function returns a double representation of the C-string argument. This code implements strlen and shows how to accept value from the user using fgets. The program includes necessary header files for standard input/output operations, studio.h, and for string manipulation functions, string. The maximum length of the sentence is defined as max_length, which is set to 100. Inside main function. Declares sentence of size max length. Prompt the user to enter a sentence. The line fgets sentence, size of sentence, stdin, reads a string from the standard input, usually the keyboard, and stores it in the character array sentence. Here's a breakdown of each part of the fgets function call. Fgets, this is a function in C used to read a string from a specified input stream. Sentence, this is the destination buffer where the input string will be stored. In this case, it's the character array sentence. Size of sentence, this specifies the maximum number of characters that can be read and stored in the sentence buffer. It's calculated using the size of operator, which returns the size of the array in bytes. Stdin, this specifies the input stream from which fgets reads the input string. Stdin is the standard input stream, typically connected to the keyboard. Then, it calculates the length of the input string using strlen function, and then prints out the input sentence along with its length. As a recap, C-strings are sequences of characters represented as null-terminated character arrays. Each string ends with a null character, \0, that marks the string's endpoint. C-string arrays have a fixed size declared at initialization, with enough space for characters and a null terminator. The string library provides functions for manipulating C-style strings. The stdlib.h header file in C provides various functions to convert strings to numbers. That's all for this video. See you in the next videos for more C programming topics.